record now. So without further ado, I present Nick Vissari, who will be doing an intro to SaltStack and a lab for us. So thank you, Nick, and take it away.
Thanks, John. Let me just share out my screen here. As soon as I figure out how to share the whole screen. Okay, I guess I'll just share one window at a time. Does this work if I full screen this? Okay. Everybody can still see that all right?
Yep, can see it fine.
And I lost the chat, so if anybody has a question in chat, feel free to interrupt and speak on behalf of somebody else.
I will go ahead and monitor the chat as long as it doesn't get too lengthy. If I can't catch it, John plays well. So
yeah, cool. I'm watching it.
Okay, so this is an intro to SaltStack. SaltStack is this is pulled straight from their website, software to automate and document. I added that part, the management and configuration of any infrastructure or application. My name is Nick Vissari. My Twitter handle is Nick Adam. I try and be as transparent as possible. So no seedy elite hacker names here. So I work at Howard County Public School System, which is local here in Maryland. And I'm a security guy and I'm a DevSecOps enthusiast. I also have my cybersecurity information assurance degree. I'm a CISP and a CCSP. So if you have any questions about that, or you want to talk about that, feel free to reach out to me. Ooh, missed something here. Oh, there we go. Sorry about that. Why does certain applications just feel they're so important they get to be on top of every other window? Just make this
elitist software.
Yeah, they're like, I get focus all the time. Okay, here we go. I want to be able to choose my focus. Okay. So as sysadmins, I assume a lot of us on the call here are sysadmins. We spend a lot of time reading friendly manuals, watching YouTube videos, reading quick starts and tutorials. And a lot of what we owe our expertise to is the ability to Google better than the next person. So we end up having to maintain a lot of that infrastructure, and we've become responsible for that. So people look to us as the professionals, and keeping track of all that is very difficult. So which system is doing what do we patch when, in which order do we patch things, such that the application remains online. How do I join my Linux system to the Windows domain again? That's always challenging. And just how do we keep track of all the things? So it's very difficult. So here's a list of things that I've used to keep track of what's going on in my infrastructure. And these are all effective methods. Shout out to all my org mode folks here at the Linux Users Group. And you've probably used a lot of these methods before. But we're still left with some problems. The documentation can drift as the system changes over time. Where do we put all this documentation so that it's accessible to the team? How do we make the time to actually document our changes? That's probably my biggest gripe about documentation, is that you read everything, you do what needs to be done. You're in this like loop of just try something, test it, try something, test it, and then you finally get it working, and you're like, now I have to stop the progress and document. So that's always annoying. And then when we share this documentation, how do we ensure that the person that we're actually sharing with it, knows that they have all the context that we've brought with us? So we know how systems are configured, we know how applications are configured, but depending on who the audience of the documentation is, they might look at something and they have really no concept of what they're looking at. So it ends up being this endless cycle of having to keep dropping down into levels as you get more and more vague in your documentation, depending on your audience. So I find that extremely annoying. So what do we do about it? We can actually stop writing documentation just for the sake of it and start keeping track of our infrastructure changes in code. So it's less less of a conversation about, how does what is Linux and how does it work? And it's more of a perceived understanding that, oh, you want to deploy an application. You need to go look at how we do that in this organization. And we do that through declarative infrastructure. So this is a list of infrastructure as code tools. Ideally, you would write your configurations in code, and then you would keep track of all that in Git. And then just by looking at the source code and the changes that are in Git, you can tell who has done what and why, right? If they're writing good comments. So that it kind of, as a constraint of actually making changes to your infrastructure, people have to document, right? You can't actually just do something without having it committed somewhere into a source control system. So, and you're no longer documenting just for the sake of documentation. You have to write your changes into a source code repository. So that's the concept there. And we're going to be talking about SaltStack, that one right there in the middle, which the reason I chose SaltStack is kind of depicted here, is the fact that some of the other ones, some of the other infrastructure as code tools, you'll see that the master in this example would reach out to the minion, right? That's a very common pattern, because most of the time people working on this, they're configuring servers. But I don't necessarily configure just servers. I actually use SaltStack to configure workstations as well. And they could be coming from anywhere, right? They could be coming from a cloud somewhere. I don't know what their IP address is at any given time. So I want them to call back to my master and then create a persistent connection. And that's what SaltStack does for me. So it's a client-server technology. By default, it runs as root and system on the client, which is extremely powerful. You can use it to run commands on the fly, which isn't actually infrastructure as code, but it's a really handy utility, especially if you're working in security. You can install software. You can update your software. You can get information about the systems. You can store information about your systems in SaltStack. And then you can declare all that code as granular as you like. And get used to those puns, because there's plenty of them in the SaltStack community. So, yeah, so let's see. Okay. So what does it look like to actually use SaltStack? So here's a little, I guess, a example of something that we have to do as a sysadmin, right? We need to install some package, XYZ, fictitious package. It may be in the package manager, for our specific operating system, whether it's, Debian or Red Hat or CentOS, or we have an installer script that we get from somewhere. So we're going to create what's known as a state. So it's going to be an installed state. And then we have to somehow describe where that state is supposed to be installed, right, on which systems. And then we finally deploy the state, and we're done. So that's going to be what it looks like. And while we're doing this, we're going to be using Git, right? So we're going to use Git to, in every step along the way that we're keeping track of, here's how we actually install it. Here's the state of it being installed. And then we actually deploy to those applications, to the servers. Okay, and we're going to jump right into a lab, which is available on GitHub if anybody wants to follow along. And all we're going to do here is we're going to start our environment. We're going to install our master. We're going to install the minions, accept keys, and test connectivity. That's going to be our first kind of step here. Let's see here, full screen. F11 now. All right. Now I think I have to, because it's not my whole screen, I've got to change share. All right, how's that? You guys see that okay?
Yep.
All right, good. So I've done a little bit of pre-work on my side because it's kind of boring. But in the repo, which I can't show because I can only look at one screen at a time, but in the repo, oh, you know what? Let's see here. Let's go to One. Yeah. So you'll see a vagrant file sitting in the lab directory on SaltTalk, and it just spins up 3 Debian boxes. So that's what we have here. We have these 3 Debian boxes, and I need my notes here. I'm going to use the Uber Elite hacker tool known as copy and paste. Let's see here. There we go. So first step is to actually install the dependencies to get Salt. So there is a Bootstrap script available on SaltStack that we'll be using. So in order to get that, we'll need curl. And I'll just do that on all 3. Oh. So install curl. And actually on the master here, I'm also going to be writing, I'm going to be actually writing the infrastructure files, the source code here. So I'm also going to need git and vim. So it's always a good idea to make all your changes in production and keep all your, source environment in production. That's a joke. Don't do that. So if this was a real setup, what we would do is we would have like a, our Salt master would be pulling down a repo from source control that we would separately be working on in a test environment. And this is a wonderful test environment. So it's pretty sufficient to figure out whether or not your installer is actually going to function. Okay, so Salt provides a Bootstrap script for us. It's right here, bootstrap, saltstack.com. So we're going to go ahead and download that. And in order to install the master, we just have this -m flag. So we're going to go ahead and install the master on this Salt. This will also install the minion. So the master will be a minion as well, which is kind of neat. We can use Salt to configure the master. And then on the minions, we're actually going to omit the little master flag. So we're just going to install the minion on these 2 guys. Oh, which you would need the Bootstrap for. Let me go get that. There we go. Cool. Get this one going. So this is going to run. Looks like our master is still going. This guy's installing. I didn't queue up any Jeopardy music. I'm sorry. Let's see here. All right. So there's a little bit of magic happening in the background here. Is that these 3 vagrant boxes actually have a Salt host entry in the etc host file. I'll show you that here. Well, this one's the master. It doesn't have one. Its name is Salt, so it knows how to find itself. But whenever Salt installs, if you don't actually specify the name of the master, which you can do in the Bootstrap script, it'll just look for any host named Salt or Salt at the fully qualified domain name of the host. So it looks like we got all 3 of them going. So now we have the 2 minions installed, and we have the master installed. So all 3 of them are actually checking with the Salt host right now. And they're saying, okay, I'm brand new. I was just brought up. So I want to find a master. So it finds the master Salt. And it's pretty boring. Nothing has happened yet. It's just called in and it said, okay, here's these 3 minions that want to actually participate with this master. They want to be controlled by the master. So nothing's happening right now other than the master has a copy of the key that it presented. There's a key exchange that happens at this point. And it's important to note that this key exchange is actually vulnerable to a man-in-the-middle attack. So you want to do this on a trusted network or somehow out of band, actually check those keys. But we trust our little setup here. So we're going to go ahead and accept all these keys. And we're just using the salt key command to accept them all. And there we go. They're all accepted. And now that they're all accepted, we can actually interact with them. So we can see that if we list all the keys, we got these 3 accepted keys, and then I can actually run a command known as test ping. So what that's going to do is the master is going to send a request to all connected minions to see if they're online, and then they'll respond back with a true. So it looks like all 3 of my minions are online, which is kind of weird to say because one of the minions is actually a master. It's neither here nor there. And then I'm going to do one more thing just because I am not used to typing sudo all the time. So I'm just going to change my bash RC so I don't have to do that. Let's just go with this guy. Oh, darn. It's this copy and paste annoying feature stuff. Okay, I give up. All right, well, I guess I'm going to be typing sudo. And screw that up. Okay, ignore that. Let me get back to my slides. See where I'm at here. Okay. I'm gonna present this. John, is there any way for me to present my whole screen? Is that something that's limited right now?
That should be an option in Zoom.
It's not a limitation that I put in place. You should be able to do it, but
Usually
have done Zoom on a Mac.
It's usually when you see the list, it's usually one of the top ones on this list.
Yeah, why, but I'm not seeing it. It's just some of my individual windows, but that's fine. I'll just keep jumping between them. All right, so let me back up a little bit. We were here, we installed the master, we installed the minions, we accepted the keys, and we've tested connectivity. So next up, we're going to run some commands. Move this over here and switch again. There we go. Okay. So running commands. Command.run. So that is the actual execution module that we're going to be calling. We're using this asterisk to just target all minions. And I don't know what I'm going to run. I'm going to run hostname. Pretty boring. So all the minions are going to respond with their hostname. I can run any command I want here. And it's running, like I said, as root. So this is pretty powerful, right? I can kind of get this set up and maybe walk away and never think about it again until I actually have to go make some configuration changes. Just get everything down to a single one-liner and just say go. Xavier.
Yes, question. When the commands are running as root, that doesn't process any aliases or anything like that. It's just the regular bash commands that are available on the system.
Yeah, it uses the built-in, whatever your shell is set to. So, and it's non-interactive, obviously.
Okay.
Yeah. So these are all running in parallel. So when I run this, when I do command run, it actually sends this execution, what's it? I don't even know what you would call it, but out to each minion, and then they run them in parallel, and then they'll send their responses back, all asynchronously. And then whenever all the minions respond, you actually get your output. Okay, let's see here. What's next? Okay, and errors are fun too. So let's grep for salt and Etsy host, like I talked about before. So you can see here, this is the magic that's going on in the background, is we actually have the IP address of the salt master in the Etsy host file. We had that set up in our Vagrant file. But if you were doing this in a network that you have, you might just set the name salt to your salt master, and then you don't have to worry about specifying the salt master, or you can, specify it using the -A flag. So if we grep for the IP address, we'll get 2 out of 3, right? So this IP address is only available in the Etsy host, and then we have this red came back, and it said that one of the minions, well, it said minions returned with a non-zero exit code. So if I was just running things imperatively like this, I could run a command very haphazardly, walk away, eat my lunch, come back. And if I don't see this, then I know everything worked So don't do that. This is a talk on things not to do. But yeah, I should preface all this with the fact that I am a hacker at heart, and I just get things to the point that they work for me, and then I walk away. So
Nick, what's the exit code on that command right now?
I'm sorry, can you ask that again?
What's the exit code on that command right now? Did the
Oh, it's
sudo
probably
command?
Yeah, it's probably 1 with grep. I'll bet it's 1. But yeah, it won't.
It's like an echo dollar question right now.
You know, I don't think I've ever because it's gonna open up a new shell every time.
Not with a sudo, just right now from your shell.
Oh, I see.
Sudo.
Oh, what does the salt come back? I gotcha.
Yes.
Yes. So what do we got here? We're gonna do $? So yeah, it came
That's
back
also
with 1.
okay. Thanks.
I don't know that it actually passed the minions. I think that's just what this salt command is actually responding with. Yeah.
Yeah, something failed, so it gives you a non-zero. So you can script off of that.
Gotcha. Yeah. Yeah, but you wouldn't want to script things imperatively like this. I mean, you certainly can, but there are other parts of salt that really make this more purpose-built, right? So they have something called salt engines that you could use if you actually wanted to script things on the master. Okay, but we're not going to get into that here. Okay, so also salt. Sorry. There's a concept called grains. So if we just look at one of the minions grains, we'll do minion 1, say grains.items. So this module is going to respond, hold on a second. So this module will actually list out all the grains for a particular minion. And these grains are stored on the minion, and it's just little helpful information that we can use to tell us about our systems. So we have CPU flags, and what is our actual disk, the domain that we're on, IP address information, the actual GPU and CPU models are in here. The serial number is going to be in here, but this is a virtual machine. Kernel. Yeah, so a lot of helpful information in here. Here's our mem total, number of our CPUs. And you can use this information to target the minions. And we can also look at these grains one at a time. So let's just say I want to get all my minions. Let's look at the OS family. So they're all Debian. Cool. We can also say, look at whether or not they're virtual. And it comes back with VirtualBox. So, oh, and this is a good one too. For our thousands of interfaces that we might end up with, I want to do IPv4. Just show me all the IPv4 addresses. And so it'll just list them out for us like that, no matter what interfaces they're on. That can be helpful too. Okay, so in addition to getting grains, we can actually set them. So as an example, if we were to look for a role, it doesn't return anything. It's because we don't have a grain called role. So let's look at setting a grain. We're going to call minion ? That will target minion 1 and minion 2. We are going to set the role of worker for these two guys. So it responded. We just made an imperative change. We have not actually written this in code. So again, don't do this. But we now have the role of worker actually set on 2 of our minions and not the master. Let's see here. Now I gotta switch my screen. Is that right? Share that. Oh, there we go. Okay, so, and I've been, my screen sharing is paused. Resume, please. Okay, cool. Sorry about that. Okay, so we can see we've been targeting minions with the asterisk, which just is all of them, but this is something called globbing. So it's shell style globbing, which is why I'm surrounding these globbing commands in single quotes, so that you can tell that, or that it doesn't actually conflict with your shell. So if we did server asterisk, it's going to be anything after server. Server question mark is just going to target any single character. We can also specify numbers or ranges of numbers in that list format with the square brackets. And then we can also specify list using the -L flag, and then we just list a comma separated list of the minions that we want to target. And then this G flag is where we actually use our grains, so we can actually target with a grain. S is really nice too, because that's for subnet, so we can actually specify CIDR network, and if we have our infrastructure set up in maybe different geographical locations and we have them subnetted, we can just use the subnet to target. We don't have to worry about setting regions or anything like that, depending on how your your network set up. And then there's also compound matchers. So we can combine these things. We can combine grains, and we can combine the globbing together using Boolean and parentheses. And then you can come up with really complicated ways of actually targeting specific minions for commands. Okay. Any questions on that so far? All right, I think we're good. So back to this example. So we need to install XYZ fictitious package. Again, we can get it from the package manager, or we have an installer script. But what is this thing called a state? We're gonna pretend this is a new term, right? So an estate is really two things. It is first a check to ensure that the system has what we want it to have. If it doesn't have what we want it to have, the state will actually attempt to install the software or set the grain or what have you. So when we define a state file, it has inherently everything that it needs to check that the thing that we want is actually set, and there are no changes needed. If it's not actually set, then we will make changes to the system to make that state true, right? So you'll see a lot of past tense with states. So here's an example state file. Salt state file, SLS, is what they end in. XYZ SLS. The first one here is the XYZ. This is YAML, by the way. And it's just using PKG installed, which is the OS. The OS is built-in package manager. So it's an abstraction. So if you're using Debian, it'll use apt. If you're using CentOS, it'll use yum. But this is something that Salt provides for us to be very helpful, or we can just interface with the package manager. Now, of course, the name XYZ has to be normalized between them. There are ways around that where you can actually check the operating system and do some fancy stuff. But yeah, for installing very simple things where, Vim is Vim and whatever platform, this is the way you would do it. And if you can't do it that way, again, I'm a hacker, so I might just find some installer script. I might have something left behind from long ago, or maybe whoever is providing the application has an installer script for me. So I'll just use that. And you can see here it's running the command script with a source file. And that source file is coming from this salt:// It's kind of curious, right? So Salt actually has a whole file storage and distribution system built in. So the Salt directory is available to all the minions. So anything you put in the Salt file store is available. So you don't actually have to distribute those files because Salt is doing it for you. Okay. So and then we're gonna keep track of what we do, right? We're gonna use Git for all this. Because I have to flip back and forth, I think I'm just gonna skip over committing all this stuff. And yeah, the fact I can't share my whole screen is a little debilitating right now. I'm not sure why I can't choose it. Okay, what else do I need? Okay, so let's go through an example. I gotta switch it again. We're gonna switch over to this guy. Here we go. All right. And move this over. Okay. So I'm gonna cheat a little bit, and I'm just gonna clone this guy. Okay. Cool. And actually, Nick Hughes is on the call, and he did some really awesome, he made some really awesome suggestions here. But I am not prepared to talk about those. So I'm going to go back to the old version. And then he can hop in here and talk about some of the cool, more salty ways of doing things. All right, so now let's look at my SRV. Oops, not that SRV, this SRV. So in the repo, we have this SRV salt directory. And for the first example, let's do something simple. Let's install ScreenFetch. So we have that folder, the ScreenFetch folder. Let's go back and let's do this. We're going to make dir SRV salt. So that's going to be our default file store. And what am I, vagrant salt. Okay, so now I want to, okay, I'm going to copy this ScreenFetch over to our store. Okay, go there. So in here, we just have the one state file, installed SLS. There we go. So that's all it is. It's just 2 lines. It's a YAML file, and we're just using the built-in package manager. So to deploy this, let's deploy it to minion 1. We're going to salt minion 1. We're going to test whether or not this ScreenFetch installer works. SLS ScreenFetch.install. So we're calling this module the state file that we've created. So the module, I'm sorry, the execution module is state.sls. And what is it looking for? It's looking for ScreenFetch.installed, which is just this path that we see here. So SRV salt ScreenFetch, and then there is a state file called installed. So let's go ahead and run that. Yeah, with sudo. There we go. So it succeeded, and we have one change. And what did I do that? I did that on minion 1. So let's go to minion 1, and we'll run ScreenFetch. Yay, it works. So that's cool. We just installed a piece of software using this state file. So I gotta switch back. All right. Share. Okay. So we tested it. It works. We had a change, and hooray, it's working. Okay. So we've created our state file. And now we have to describe where we want to install it. So we just ran a command to test it, and we installed it. And we could, you know, just run that command and install it on all of them. We can change the minion 1 target to just everything if that's what we want to do. But that doesn't really describe to our colleagues where we're actually deploying this package. So what does that look like? So we have a, Salt has a top.sls file, which is called whenever minions apply what's known as the high state. So if there's a way, this is the way, I guess I should say, that you describe where you want things to be installed using the top file. So by default, it's base. There's others you can use. You can use dev, you can use test, but by default, base is the one that's going to get called. And then, so in this example, we're going to do minion question mark, which is going to be our two minions, not our master. So let's switch my screen again and show that. Okay. So I'm going to go to SRV salt, nothing here. I'm going to vim top.sls and base. We're going to do minion question mark. So now that we have our top file, the last step, this is really worth switching. Yeah, Okay, the last step is we actually deploy everything. And I mentioned this before. This is the high state, right? It's where we actually apply the top file to our minions. Let me switch back. Haha. Okay. All right. So to do that, I keep using sudo. It's my aliases. Okay. So let's just apply the high state to all of our minions. Right? State.apply. So each minion is going to go look in the top file. It's going to see if it has any work to do. There we go. It's going to look to see if it has any work to do. And our first one, so Salt came back and it said that no top file or data match is found. So we don't actually have anything in our top file that pertains to the minion Salt. So minion 1 and minion 2 both have work to do, but Salt doesn't have anything to do. So what you'll find, some people will put just kind of a benign command in the top base file, just so that whenever you call high state, you're kind of ensured that you won't get these errors, because you should always be able to call your high state on your minions. Okay, so we had one change for minion 2. Scroll up here, and we have succeeded for minion 1, but no changes. So that's the state file. Like I said before, you know, if it's already there, it just checks to make sure it's there, and we don't have to make any changes. But if it's not there, it does the installation. So if we go to minion 2, we can run fetch, and hooray, it's there too. So cool. So we just described where we want that to be installed. Oh, I'm already here. Yeah. All right, so let's do a more complicated example. Let's install Go. Sheet again. Service Salt. Oh no, that's not there. It's in Vagrants. Salt talk. Salt. Right? Yeah. To survey. Go. All right, so we have two files. We have our installed state. Okay, and this is the example where we're going to use a shell script. There are better ways to do this, and we're going to look at those next. And if we look at our installed shell script, this is pretty much exactly what you would get from the Go webpage. Whenever you the golang.org webpage, is that there is a file that they publish. This is Go 1.14. New versions are out. So we're gonna check to see if Go exists in the binary path. So if it did exist, this block of code, this top block of code, wouldn't actually run. So if it doesn't exist, we're going to change our directory to root, download the file, extract the file, and then we're going to remove the tarball. And that's the equivalent of installing, Go from the tarball. And then the next thing that happens is it's actually going to check to see if the Go path is in the profile, the default profile or the global profile. So again, if the return code here is 0, then it won't run. But if it's anything else, which grep will give us a 1, and it'll say that we don't have that in our profile, then it'll actually put it in the Etsy profile down at the bottom. So to ensure that we actually have that long bin path. Okay, so that's there. And let's go modify, well, let's test it. So I'm gonna salt minion 1.
Do you have a moment for a question?
Absolutely.
So you're saying this is a state file. What is this? I'm not sure I see what makes this a state file versus just an action. Yeah,
so that's a good point, because it is just an action, right? It's the execution module is command script, so it's going to run every time. So let's run it the first time, and then I'll run it a second time to kind of show you that, yeah, right, it's sudo. You're right. It's going to run every time, and it's kind of we're hiding the fact that that Salt does not know whether or not the shell script has made any changes, right? So if the shell script runs, it just says, yeah, succeeded. We made a change. We ran the shell script. So it's kind of relying on the fact that, you know, we know what we want our shell script to do. So we says it succeeded, and there's one changed for minion 1. So if we go to minion 1, I'm gonna log back into it, and there we go. So we have Go installed on minion 1 now. And if we run it again, you know, that took some time to run. I don't know if people are paying attention, but it took a little bit of time to run. There you go, 18 seconds. So if we run it again, it came back in 72 milliseconds. So it still says that there was a change made, but it didn't actually, the change was the fact that it ran a script. But the script didn't actually do anything because we know the contents of the script, right? The Salt master or the Salt system doesn't really know what's going on when we execute that script. And that's not really a salty way to do it, right? That's kind of just a hacky way to get the install out there. Let me see. Go installed. Okay, so let's, now that we've, does that answer your question?
Sort of. I'm still trying to figure out why this is called a state, but that's fine. Go on. You make it.
Okay. Yeah. So it's called a state because it's actually recognizing the absence of Go and installing it, or it's checking that Go exists and no install needs to occur. So we can actually deploy this script for all intents and purposes to any number of systems, and it will actually install Go for us.
So I'm sorry to keep hitting that, because it sounds to me what you're saying is Salt has his own, I guess, facts file or whatever you want to call it that it has about what the node is. So what if someone else had installed Go on this box outside of Salt? Would it see that?
Yeah. So it would actually, the script wouldn't do anything. So it would just do those 2 checks that we saw. So salt go install.shell. So the script would look for this file, user local bin go. If the file existed, it just, okay, whatever. It doesn't have to be a valid file. It could be just it could be an empty file, and it would say, oh yeah, that's fine. You must have Go installed.
It may not even be Go. It may be a different version. So
right. Yeah.
At this point here, the state is whether there's an well, actually not even executable, whether there's a file there. That's
exactly. Yeah. So this is very, like I said, this is a hacky way to do it. Not great. And there's a much better way. So and actually, I think I'm going to skip over NetData because that thing is just, it takes a long time to install. Okay. So let me show. Actually, I'm gonna pull in the other version, and we'll do a little comparison. No, it's not there. It's under Salt Talk. We're gonna check it out. All right, and let's go look at the Go installer. Salt Go. So this newer version, more salty version, doesn't have a shell script, right? And if we cat installed, we have all this. And I think I want to hand it over to Nick Hughes at this point, if he's available. And he can talk through.
Yeah, sure. So as Nick was saying, first Nick, not me, the state enforcement was in the previous version was really offloaded to the script, right? You know, the state module being used was command.script, and it was relying on the fact that the script was written in a somewhat idempotent way in order to run multiple times and not do the same actions over and over again, right? You know, it was checking for the executable file to be there before it was going to do anything. You know, it was really the logic inside of the script that was being stateful in that regard. But Salt's built-in state modules, and there's a ton of them. If you were to look on their documentation website, there's a lot. So, you know, definitely rely on their documentation. There's absolutely no way that you remember all of them. But you can see instead of a command.script, what we're doing is we're using two different state modules here. We're using archive extracted and file managed to do basically the same things that were inside of the script, but offloading that to Salt's state modules instead of having to write that logic ourselves. So inside of archive extracted, that's taking on pretty much the installation portion. So in the shell script, it was using wget to download from that source location, which is the second line under archive extracted. And then there was a tar line inside of the script that was extracting that tarball to user local. And really, this whole archive extracted segment of the YAML is doing the same thing. So it's pointing us a source location, so we don't have to do a separate wget. Archive extracted just knows how to go and get web locations and download them. It's going to download it to the Salt cache location. Then it's going to extract that tarball to user local. So we'll end up with our Go binary once that's extracted. Skip verify is a lazy action. That was basically put in by me because I didn't want to go find the hash of that tarball, but in production, you're going to want to do that, right? You know, when you're installing software from untrusted locations, you want to make sure that you have the hash of that. So skip verify is me being lazy and not putting that hash in, but then we're telling it that it's an archive format of tar. We're passing it a Z option to tar, so it ungzips it. Enforce top level is an option, and all this is in the documentation for each one of these parameters. But enforce top level is basically saying that you don't have a root directory inside of that tarball that's going to get extracted. I don't know if you guys have ever heard of like tar bombs. You could put like n number of items at the root level of an archive, and when it's extracted, it just like inundates the system. Top level is going to give you a safeguard, but the Go binary doesn't have a top level directory. It just extracts multiple things at the root level, so we have to turn that off. And then fail hard is a global parameter that we can pass in so that if any one of these states, if you set fail hard on it, it'll just stop right there. Otherwise, Salt will actually keep going and try and do things farther down in the file, right? So like Salt in this scenario is top to bottom. It's going to do archive extracted before file managed. And if I didn't have fail hard in there, archive extracted might fail, and then it will still try and do file managed below it. So if you have a lot of different things that you're doing inside of a state, and they're all relying upon something to go right at the very beginning, you can accomplish that enforcement a couple of ways. But the easiest one is to just fail hard, stop right there. If it errors, you're not going to do anything else. Overwrite allows us to overwrite the Go binary if we so choose. And then unless is actually what's called a requisite. And there are multiple requisites, and the documentation does a good job of explaining them. But in this case, it's basically just a shell command that we're using as a test to see if a condition is true or false, right? So we are going to perform that archive extracted unless we're going to check the current Go version against a static string, which probably isn't the best way to do it, but this was kind of a like quick and dirty thing that I did. We're going to test the existing Go version against a static string there. So you could use that in order to upgrade Go, right? Like in the first shell script, it was just checking to see if the binary was there. What this allows you to do is check to see if it's a specific version. And that way, if Go 114 becomes 115, then we can go ahead and run this state again, and it'll just get the new version. which is pretty cool. And then file manage is dropping a profile script for us so that the go path is in our shell path, and we can just run go from the command line. So yeah, this is the saltier way, as Nick put it, to do the same thing that was in the shell script, and do it with native salt commands that do a lot of the hard work for us, right? We don't have to write all of that logic in order to check things. There's a lot of Python code in the background that are doing those checks for us.
Awesome. So yeah, this is a lot better than the way that I was doing it before, and this serves as a great example for me going forward in production if I actually get back to making production changes. Right now we're all at a standstill because nobody can walk in the building. Okay, so what am I going to do? I'm going to copy this installed shell or installed state file, and just to show you guys that it does work. So what are we doing? Salt. There we go. Go. All right. So, and then actually in SRV salt go, we have the shell script that we no longer need. So we're going to go ahead and remove the shell script. Right. There we go. So I'm going to go ahead and run the same command here. There we go. On menu 1. And looks like file managed is going to change because that's not there. But archive extracted should be fine. Assuming Go version runs. I think that would be the only issue, is maybe Go version. Salt doesn't know about Go because of the profile load, but we'll see. We'll see what happens here. Cue Jeopardy music. Ooh, nice. Okay, so it did actually do the extract. So I think that might be, we might have a little bug where maybe the Go version doesn't work. Let's try and fix that right now. What am I doing? Let's just do this. I think that's probably the issue. And I'm going to go ahead and change this guy. Oh, freaking paste. All right, what is it? User local. User local go bin go. Okay. User local go. Let's try that. Well, I guess we're just cursed. But trust us, it is it's a lot of fun doing things in state files, because configuring thousands of systems at a time can be really annoying. So yeah, Salt has really been a lifesaver for me. Boy, I don't know why that wouldn't work. It did it again. That's cool. Okay, so obviously we got a problem with the unless, but otherwise it still works, right? It just takes a little bit longer. So let's see. Let me switch over here to this guy. I'm not going to go through this part of the demo because it does get pretty complicated. But yeah, there's it. Why does it keep pausing? Resume. There we go. Okay. Where was I? Okay. So top SLS. Okay. Yeah, I didn't talk about this. We didn't do net data. Here we go. So the top SLS file that I showed you before, we can actually use the grains and components, or compounds, grains, compound matchers, lists. We can use those all here. The only difference being that instead of the -L command that you saw, or the -G command, it's going to be the G@ symbol. So it looks like a compound matcher in the YAML file. So here we're just showing that, we have the minion question mark for screen fetch. We just installed Go to the Salt minion. And then we have the grain for anybody who has the role of worker for net data. So that's what these three deployments look like, where we're actually deploying that software. And then, okay, so there's another concept called pillars. So it's the same thing. It's a tree-like structure of data. And we defined our pillar on the Salt master. And the difference between the pillar and the file store is that the pillar actually isn't available to all the minions unless we explicitly deploy it to the minion. So that's helpful for secret-like information. I wouldn't put all your secrets in here because, you know, it's going to be in your source control ideally, and there's better ways to manage your secrets. But if you had like some data, as an example, here's an example where we're taking some user data, which is, these are just 3 users and user IDs. It's just stored in a YAML file. There's nothing special about this. We're deploying this YAML file to all users, or I'm sorry, all minions, right? The user's pillar is being, or the user's pillar is being deployed to all minions. And then we can actually use that data source to write our, or to create our state files so that our state files can be a little bit more dynamic. So here's a example, right? Users init, and this is using Jinja. It's a little bit of Python looking stuff, but it's a templating engine, Jinja. And we can loop through the user's pillar, and then we can create what looks like a different YAML file, right, from that template. So if you can kind of see, I can't really use my mouse. You guys can't see my mouse, I don't think, so I can't really point to this, but where we see...
we can see your mouse.
Oh, you can? Okay, great. So right here, we have the... cool. So yeah, we can see that this user variable is being set right here. It's getting it from the pillar. And then that ends up being right here. So here's our 3 user variables, Nick, Tim, and Jen. And then this is just something we declared explicitly in the template or the save file. And then it expands it out. So we're just going to have the user ID 30,001, 30,002, 30,003. So rather than having to maintain a state file with everybody's name in it, and this could be a lot more complicated looking, you know, if you are actually keeping track of people's public keys for them, you know, that's one example. Maybe you're pulling them down from GitHub or whatever. But yeah, keeping track of all that stuff can be annoying. So it's a lot nicer to actually, you know, write it here and then use this information over here in a more like a compiled or interpreted way. So, and then we can actually use that pillar data in different things. We don't just have to use it for, you know, it's not a one-to-one type of relationship. We can use the pillar data anywhere. So this is helpful for like I've used it before for distributing keys, or even creating pillars that actually had virtual machine attributes in it, and then a state file that would actually take those attributes and deploy virtual machines. So it would say what the host name of the virtual machine, how much memory, how much CPU you want, and then it would deploy a state file that actually spun up virtual machines. So it was a lot of fun. And that's pretty much it. You know, like I said, I don't want to go into the demo there because it's never works out well. But in summary, so SRV Salt is really telling us, you know, what is deployed and how in the state files. The top file is really telling us where we're deploying our states. Git is telling us who did what when, right? And the SRV pillar, we can store kind of secret stuff, but it's great for Jinja and templating. And then top for the pillars, top tells us where the data actually goes. And some extra bits. Docs.saltstack.com is where all this information is available, and they actually have some really nice tutorials on there if you want to go through them. But yeah, the documentation is really good, and there's other modules. There's tons of modules that are out there for different applications even. Python, YAML, and Jinja are our friends in Salt because we're going to be writing everything using these 3 languages. Salt SSH exists. It's a clientless way of doing Salt. So if you have maybe an IoT system that you can't actually get a full-blown minion installed, but you can do SSH, or even some network gear, maybe you got some switches or a router that you can SSH into, you can actually use Salt SSH to declare the configuration for those devices. Salt Mine is a dynamic data that you can actually, think of it like grains on steroids, where the minions can actually share information with each other through the master. So this is good for, like, I've used it. This is really for, like, if you have some production level data that you might want to share amongst each minion. So like the state of how they're currently running. Maybe you're balancing, maybe you have some kind of way of balancing information or balancing sessions between servers. SaltMine would be a good way to kind of keep track of that. And then runners are convenient programs that you can actually run on the master. So I haven't really looked into runners too much, but there's one runner that is kind of exciting to me, and I will eventually look into it. It's the Dell remote access card DRAC, the DRAC config. So you can actually do the interface with the DRACs from a Salt runner, which is kind of cool. And I think that's it. Yeah. So go forth and DevOps and try and have fun. And I'm certainly here for any questions that you might have. Unless you want to, John, maybe stop the recording, or I'll let you.
We'll let the questions go in the recording.
All right, cool.
So Nick, there's kind of a crowded field out here. You've got the Salt doing a little bit of the stuff for configuration management, but there's also Ansible, Chef, and Puppet. When would you choose this over some of the other competitors out there?
Yeah, so we had a very robust discussion about this on the DevOps group. I can give you kind of my simple answer, which is, I was looking at Ansible and Puppet and even Bolt. And really it was the client side of Salt, the fact that the minions call into the master, and that there is this event bus that is kind of constantly there. So when a minion actually calls in the master, it creates a persistent connection. So it's real time, right? So you don't actually have to, like in Ansible, my understanding of it is that, I would have to, from the central point, make calls out to servers that have to be up and hosting a service, a listener that I can actually connect to. In Salt, the clients are actually, they have a persistent connection back to the master with no listener, right? So the master is just sitting there with the listener open, waiting for clients to connect. And that was what led me there. Once I got there, I realized that Salt does a hell of a lot more, and is way more tailored, or at least it has a greater destination than just configuration management, right? You can actually from Salt use Salt as your orchestration tool for configuring, not just configuring your systems, but also keeping track and monitoring and changing your infrastructure kind of on the fly to respond to changes in the environment or changes in your the usage of an application, even doing things like incident response, right? So you'll see a lot of in the Salt documentation, the Salt website, a real heavy focus on security because of this real-time nature and this persistent connection. If I get feeds of compromised hosts or vulnerabilities or whatever, I can actually respond to those in more close to real time by setting up things like, runners, engines, even the Salt Mine.
So the security aspect on that brings up a different question. You mentioned there's a risk of a man in the middle when you're first setting up these clients, and then you just approved all the remote clients there. What's the risk of accepting one of these clients that's not, or one of the minions that's not trusted?
Yeah, evil minions, right? So that's a really good question. It's a little like side project of mine to actually see how many people are out there accepting minions just on the internet.
I mean, from the minion side, the minions accepting work, it's not pushing commands up to the master, is it? So it's only accepting workload from the
Right.
master. So
Yeah. Well, the thing is, if you set up your master such that you don't have any confidential information in the store, the Salt file store, then, you know, what do you have to worry about other than everybody knows how your systems are configured, right? That's not necessarily a good thing either. But yeah, anything that you actually store in the Salt, the file store, is available to any minion. So if you accept, if I'm an attacker and I point my minion to your master and you accept my key, I have access to all that information. And there's also some, like I touched on pillars. One of the guidance with pillars is that you really don't use grains to target who's going to get pillar data, because the minions actually set their own grains. So if I hop onto your master and I see that there is a state file that's using the grain confidential, oh yeah, I'm going to set my grain to confidential and be like, confidential true, and then I'm going to run my high state and see what I get, because I might get access to pillar data that's, you know, secret keys or things like that. So yeah, evil minions are a thing. You really want to avoid them. I know there was a vulnerability just came out a couple weeks ago with the Salt Master. I don't know if you guys saw, but yeah, they had a vulnerability where, you know, if your master was exposed, you can actually anybody can actually run commands on the master. Which, of course, since the master has access to all the minions, you know, you can run commands anywhere in your entire infrastructure. So yeah, it's you're putting a lot of trust in the configuration management system, but that's one of those problems where, you know, you can't with great power comes great responsibility, right? Good old Uncle Ben. Having an infrastructure set up like this with Salt is extremely powerful. And also something that you have to pay a lot of attention to. Nick Hughes and I were talking before we hopped on. We were surprised by the number of people that were talking on the on Salt's GitHub issues of just like, hey, we see like this crypto miner thing running in our infrastructure. Like, what kind of bug is this? It's like, no, it's not a bug. It's like you exposed your master to the internet and somebody compromised it. So yeah. It's cool and dangerous and exciting and powerful.
Nick?
Okay, cool. Any other questions?
Yes, I have two quick questions. One is, beyond the official documentation, is there any good references that you're using and you can recommend? And the second question is there any additional module or component that we can use for monitoring, like checking, you know, this amount of CPU of memory that is in use, or it's something that we need to make by ourselves?
Yeah, so documentation-wise, I've never really had to stray from docs.saltstack.com. I mean, there's a lot of information there. It's very well organized. And my only criticism is the search is a little clunky, because every time you search for something, it opens a new tab. But, you know, whatever, little issues like that. But no, I've not really needed to go outside of the built-in docs. I guess it's not necessarily true. The only other place I've gone is actually to the Salt source code. So it is open source, which I probably should have led with. But yeah, you can actually, you just pull up the source code and you can take a look at, you know, how is it doing what it's doing. And there's a lot of fun nuggets in there when you're trying to do something. You're like, I don't know how to do this, but I know SaltStack does it. So let me go look in their source code and see how they're doing it. So that's been helpful to me as well. Now, as far as monitoring goes, so there is the Salt engines. I do believe, I've never used it, but the enterprise offering has something. Nick Hughes, do you want to weigh in on the monitoring aspect of it?
So even at the enterprise level, there's nothing that is a true monitoring system. But as Nick alluded to, the main wonderful thing about Salt is the event bus, right? You know, it was originally built as an event-based automation system generally, right? You know, we went over some configuration management aspects of it today. But, you know, it can do incredible amounts of things just because there's constantly an event bus in the background that's understanding what's going on out in the world, right? You know, it's receiving signals at all times, and you can react to those signals. So it would be somewhat trivial to write what's called a beacon, if there isn't one that exists already, to track something that you care about. So, you know, let's say you had a particular file that was very important to you on minions. A beacon local to the minion could track that file and see if it was modified. If it was modified, the beacon would know about it near instantaneously and then drop an event on the event bus for, you know, the master to act on. The master is constantly listening to that event bus, and it sees that tag come in and says, oh, you know, my special file has been modified, and then you can do something, right? So say you always want to keep that file in spec, it could run a state against that one minion that has the changed file and bring that file back in spec. So, you know, you can leverage that event bus to whatever ends you require. But, you know, it wasn't necessarily, it's more of like an if this then that engine, more so than like this is my monitoring system, but you could certainly build a monitoring system on top of it.
Thank you.
So, Nick, one of the things that really intrigues me is that you said you both do pull and push. So I would like to hear from your perspective, when would you use one versus the other?
Yeah, so I guess the push aspect of it, which I'm just going to call the imperative rather than declarative. So I mean, push pull is really, so there's two. Let me talk about two things. Let's talk about push pull. So pushing would be, I'm on the master, and I'm going to run a command, and it's going to go out to the minion, and the minion is going to run the command. Pull is, I'm sitting on a minion, and I'm actually making a call into the master, and then the you know, whatever information is available on the master, I can call in. So pull, for my purposes, has been really helpful for like just development side. So I can hop on a minion, I can do my development there, and then I can just do a salt call, which will actually run calls against the master. So the master, you know, the minion is actually pulling things in from the master. So that's one option is development. Also, I think I should probably talk about the high state, right? So the high state, I was actually running from the master every time. So I'm saying, you know, I want to call this high state, but by default, the high state doesn't actually occur. You actually have to set up a system to kind of define how the high state is. And there's some, you know, settings that you can set in the master so that the minions start calling the high state, or you can actually use the pull method so that the minions actually call their own high state. That's another useful option. So you could, I mean, it could just be as simple as a cron job that just says, you know, salt call high state. And then the other part I was talking about was the declarative imperative. So that's another concept that I think is important to understand, is that, you know, in one aspect, we're going to declare what we're doing by writing state files and actually putting them into our SRV salt and deploying them, and, you know, keeping track of source control. And then outside of that, we can actually run commands on the fly, right? And that's more the imperative side of things. So if I'm doing research, if I'm sitting down and my infrastructure is going, okay, I need to, you know, I got this call and it says I got to run this virtual machine and it needs gobs of memory. So I'm like, oh, damn it. All right. Rather than go to some spreadsheet somewhere, I'm just going to sit down at Salt Master and I'm going to just run the free command and say who in my infrastructure has a lot of memory available that I need like right now. You know, so that's a pretty useful little utility, you know, that's available to you all the time. So I've used the imperative part for just, you know, kind of research and just looking at the state of things out there. It's also really helpful for incident response. So we got hit with some malware, and as I said at the beginning, like we actually have Salt deployed to all the clients. So I needed to get a handle on who was infected by this malware, right? And Salt made that really easy for me. I mean, better than our EDR platform at the time. which was incredible. So yeah, I was able to just run a few commands and tell, get a really good idea of like who's actually been compromised. And as soon as those systems are identified, I could just say, okay, shut down the interfaces. It's done, And then I have the serial numbers, interfaces are shut down, don't have to call the network guys. I'm gonna go just take care of these systems that are now currently offline.
So the Puppet, like Puppet does the polling model, which isn't real time like everything else, and sits the client reaches out to the server. Ansible, the server reaches out to the client, so the network who sends the SYN is backwards, is backwards from each other. Salt, my understanding is the minion reaches out, so the SYN goes towards the server. So that's probably why a lot of minions are publicly on the internet and stuff, because they have to be reachable and everything. So the one thing that's interesting that neither one, like Ansible and Puppet, don't maintain a connection all the time. They're more event-based. Ansible's a little closer to event-based because you kick something off on the server and it walks your server list to go do something. The SaltStack, at least last time I played with it, it actually maintains the TCP connection the whole time through. Have you had any issues with it crossing a NAT, keeping a NAT open? What happens if the NAT resets? What happens if the firewall resets the NAT? Does it rebuild the connection? All that, and probably not a big deal if your minions are sitting right next to if you're in this area where you've got, a spread out, some security areas in between. Do you run into NAT and other networking? Does it rebuild its connection reliably? I guess is my question.
Yeah, totally. So I really have not had to think about where the minions are. So like I said, I actually have it installed on workstations. And when people, and prior to this vulnerability, I did have my master on the internet. I've taken it down because it's not yet, I'm not confident enough yet to bring it back online. But we'll do some more work there. And I don't really need it right this second. So, no reason to have it, not to have it online. Or whatever, offline. Anyway, yes, it does rebuild the connection very quickly. So I think Windows is a little bit slower. It does take some time, and I haven't run the latest whatever 3000 version of the Windows agent. Also, I've been running it since it was Python 2. So I do have some really old minions out there because there's thousands of systems, and we have a total of 9 technicians to handle all that. So, yeah, I try not to make too many changes that might be disruptive.
The problems you run into with persistent connections, though, is, like if it rebuilds the connection, but like when a firewall or a NAT times out, neither side, like if it tries to reach out and gets a reset back, it knows, oh, I got to reconnect.
Yeah.
Whereas if it just goes silent,
Right.
There's a back end timeout or something. It's got to go figure that out and then go refresh, send a new, because stateful firewalls, right? They'll drop both sides, and neither side says go away to make it rebuild it. So
yeah,
like I said, that's the thing I found was interesting. We had it running in a place, and I don't know, 200-300 connections, and seemed to handle it fairly well. I'm just curious if it could ever exist outside of the same network it's in control of.
Yeah, I've not had any issues. I do know that that there are some maintenance operations that happen on the between the minion and the master. So there's some traffic that's happening even whenever you're not doing anything. And there's probably a heartbeat. I'm not sure. Maybe Nick Hughes can hop in and see if he has any insight.
Yeah, I want to draw a distinction real quick. So when we first started talking about push versus pull, Nick was talking about it more at the logical level, right? And then John, you brought up more at the network stack. All the traffic by default is 0MQ, so it's a 0MQ pub sub. You have 2 exposed ports on the master for job publishing and things of that nature, and that's really what it is, right? Like from a network perspective, the master isn't actually ever reaching out for any purposes. It's always the masters calling in, as you noticed, John. So, from network traffic perspective, it's always that way. I'm sorry?
Always the minions calling in. I thought I heard master.
Yeah, did I say the wrong thing?
I'm trying to pick nits. I just want to make sure I got SaltStack's
Yes.
not something I know a lot about. So.
Yeah, the minion always calls in the master, always. What the master's doing is publishing jobs for the minions to come get. So from a logical perspective, it's who initiates the connection to, like who initiates the job, I guess, is the better way to put it, right? Like if the master is holding a list of jobs for people to do, you can either at the master level say, hey, I need this information from a minion, I'm going to publish this job. Or as Nick noted, you can be on a minion and say, I need to high state, or I need to run this job, or whatever. And it initiates the job itself. But either way, the minion is always initiating the network traffic. And if you look into the ZeroMQ, I don't want to get too deep. If you look into the ZeroMQ like network traffic and kind of how it works and how resilient it is, it'll make a lot more sense.
Yep, that makes sense. I get it. Thank you.
So in that sense, how do you ensure that the agent, or whatever we want to call it, on the minion side stays up? What happens if that's not running?
Yeah, if it's not running, then you're SOL. I mean, you can do things outside of Salt. If you're familiar with your infrastructure, you know you're going to have problems like this. So like I said before, you have Salt SSH.
Right.
So if your minion's not calling in, but you can see that there's a TCP 22 open from something, then yeah, you've got problems. So, but it's not something that's completely out of your control. But I can tell you from running Salt minions on Linux, it's rock solid. I have had issues running it on Windows. But those are older clients.
So it had nothing to do with Salt, but it was another agent-based system where you had, a master, a group of masters, and tons of agents. I had several thousands running. The problem wasn't the Linux systems they were all running on. It was the humans going onto those systems doing weird stuff that made those agents all of a sudden not respond anymore. Which of course meant all of a sudden we had machines or systems not being managed anymore. And it was one of the things that made me sour against the agent-based thing is once you had that many boxes, it was getting quite complex to manage. And I was just wondering how you deal with that when you have things at scale.
Yeah, so there's multi-master setup is a whole nother topic and can get real complicated. But yeah, you can actually do like a multi-master setup, even like high availability type things. You can balance the traffic around. You can have the systems call into different masters. So yeah, there's different ways to kind of I guess account for those. But if you have a firewall or something that's going to block the outbound connection to the master, it doesn't really
My
matter.
problem was I had other people that would literally install stuff that would, let's say they would open the same port that I was on, and it had to kill my process.
Yeah.
Not on the masters, but on the machines, which
Right.
meant eventually you would have almost constantly about 5% of those thousands of boxes would be unreachable because someone had done something.
Yeah, well, one benefit is that the minion doesn't have a listener, so that problem's gone. It's really just that one process, right? It's that process has to live, and the outbound traffic has to be permitted. As long as those things are there, then you should be okay. You may have other problems with like the disk being full. That can be a challenge because there is a Salt cache that is pretty important for things to function. But yeah, things can go wrong. So it's not perfect. That's for sure.
Yeah. You see a lot of people deploying watchdogs too for the minion side, right? Like the service goes down, some sort of watchdog restarts it.
Well, if it's Linux, systemd will keep it running also.
Yep.
Or try really hard to. Let's put it that way.
Yeah.
You break the config, you break the config. You're screwed regardless. But if it dies, that's okay. The other thing too is replacing Ansible replacing Salt with Ansible. Yet because of who sends the SYN, I guess you flip the network stack on its head because it's got to be reachable by everybody.
Yeah, definitely. That's one of the main things that is problematic when you have distributed networks like Nick has, is ensuring that you have access outbound from whatever your control location is to all of your different systems that need to be managed. And that's why it's much better to have this type of workflow where they're calling into a centralized location, because that's a lot easier to manage the network security for.
Cool. All right, any other questions? All right, well, thanks everybody. I'm gonna let John Kennedy wrap up.
All right, thank you very much, both Nicks. For those who don't know, Nick Hughes, who has been helping Nick Vissari out, I believe you work for Salt, correct, Nick Hughes?
I do not.
Oh.
I actually run a automation consulting business, and we are a SaltStack partner, so I happen to know a lot about it. But I've been using it before I even had the business. So, long-time user, and I'm a fan. I also am the cloud working group captain for the Salt open source community.
That's where I got mixed up. Okay.
Yes, so we are an open source community. We're pretty active, and if anybody wants to get involved, it's a lot of good people there. It's a Python code base, so if you know some Python or want to learn some Python, definitely come chip in.
Awesome. All right, and Nick Vissari, is there anything you would want to promote that you're doing or that you do on the side, etc.?
Oh, the only thing I can think to promote is stay at home, please. Let's try and get this. Let's try and get through this as quick as possible.
Yeah, no lie. All right. Well, thank you both very much. I appreciate it. It was an awesome presentation. I am going to stop the recording now.